session on no code statistical analysis and machine learning. Actually, the last session, if most of the participants were present, so like we have already done what is machine learning, what is statistical analysis, and how it was used. Okay, but right now we are interested in knowing how actually we want to implement the statistical analysis and machine learning using some tool or using Python. As I in last session, as I told about various tools, various techniques, or various languages, programming languages that are used for machine learning. So right now in this session, I will only focus on a single tool, Orange data mining tool. Okay, and so this is the outline for it. First, I will introduce you to the Orange data mining tool. Second, I will tell you how to load the data set into it, how to perform statistical analysis on that data set, how to visualize the data, and from visualizations, what we can understand, then what are the various classification algorithms, and what are the evaluation matrices for it. Okay, so like if you have any questions, just note down the slide number. Actually, I think this I have to go. Yeah, here is a slide number. So just you can note down the slide number and a question. So at the end of the session, we will have a question answering session. At that time, if you can tell me the slide number which you are targeting or just a question, that will be fine. Then I can answer. Okay, so we will start with the Orange tool. So see, this is the first screenshot as you open the Orange tool. Okay, I will show you practically how it is going to be. So just if you can see my screen, I'm searching Orange. It is already installed here. So I will just double click here. So it will get open. So I can tell you this is the first window that will appear when I will start a Orange tool. So here you can see I am using the Orange data mining tool, having the version 3.32. So this is the first page that I received. Now this is actually the Orange tool. Okay, so this is the first window that you receive. Fine. Now, if you want to load the data set on which you want to work, you have to either select the file from here, or you have to select the CSV file if your file is a CSV format, or you have to, if you want to load the data set from the online repository, which is already available in the online repository, then use this. If you want to use SQL table, you can use SQL table. But right now, I'm simply using a file to load my data set. Just you have to drag and drop. Just click on this file, it will appear. So it's like just drag and drop, or you can just drag and drop here like this, or just click, it will appear. Okay, so every widget like here, data, transform, these are known as widgets in Orange. Okay, so first I'm using a data widget and I'm loading a data set. Now, I will take a very simple data set of which is very well known in machine learning. The beginners generally use that data set. So see, already Orange tool have a set of data sets available. Orange tool already has some set of data sets available, like Brown selected, heart disease, housing, iris, Titanic, and zoo. These are the few data sets which are already installed along with the Orange tool. Okay, so you have to, I'm selecting suppose iris data set. Now iris is a flower data set. It's a flower data set. There are 3 different types of flowers, and you are classifying this data set into 3 types of flowers: Iris setosa, Iris virginica, and Iris versicolor. Okay, so as soon as you select the Iris tab, again I'm repeating, double click on this, go in the Orange folder, Orange data sets, you will select the Iris data set and open. Once it is selected, automatically it will detect the number of instances and which task it is for. So this is known as the Iris flower data set. It is a very famous data set. Even if you type on the Google Iris flower data set online, so you can download it. So it is very famous data set. So this data set consists of 150 instances. 150 instances means it has 150 rows. Okay, in 150 rows, there are 5 columns. So these columns are 5. The first column is sepal length. Sepal and petal are the 2 parts of the flower. So sepal length, which is type numeric, it is a feature we will consider. Sepal width is also one feature. petal length, and petal width. These four are considered as feature. And iris is a categorical variable having three values: iris setosa, iris versicolor, and iris burgeoning. So actually what we are doing, we have taken any sample data set. See, actually, if you are getting confused, I'm again repeating that we are working on machine learning algorithms. That's why we are loading any sample data set. You can use any data set of heart disease, of detecting diabetes, of detecting if you want to classify cats and dogs, if you want to classify animals, any. So I'm just selecting this iris flower data set where we are classifying three different types of flowers based on sepal length, sepal width, petal length, and petal width. Okay, so these four are considered as the features: sepal length, sepal width, petal length, petal width, and iris is a categorical variable. So that's why we are changing. You see, you can change the role of this here also. So automatically actually detects that it's a feature. So if sometimes you want to skip it, so you can also select skip. If you want to select it as a metadata, you can select it as a metadata. So if you will skip, it will not be considered for the classification process. If it is a metadata, it will not be considered for the classification process. Okay, so feature will be considered for the classification process. And for classification, there is a need of one target variable, which should be categorical. Okay. In classification, you need a categorical variable. Last time we have discussed that. So here we have three categories: iris setosa, iris versicolor, and iris virginica. So I'm saying apply. Okay. So once I apply, it's applied. Now I want to perform statistical analysis and do the visualization. So we will go back to the slides. So we are performing statistical analysis. Now, how to perform the statistical analysis and where are the widgets? Now see, in the data widget, there is one rank. What rank will do? Rank will tell you which feature is playing very important role in classifying the flowers. Which feature among the four: petal length, petal width, sepal length, sepal width, which feature is playing very important role in classifying the flower into three categories? It will tell you this. So if I will connect this file to this, just you have to drag and drop just from here to here like this. Just done. So when you will open this, here you will find the rank. Now for rank, there are various methods, like information gain is a method, information gain ratio is the method, Gini decrease, ANOVA, chi-square, x-square, that is relief F, FCBF. But generally for statistical analysis, there are two basic methods, ANOVA and chi-square method. Okay, so whichever method you want, you have to select from here. I want ANOVA, so ANOVA result will be available. I want x square, so x square result will be available. Okay, now see what this result means, what this rank means. Here, rank means that sepal length is having 119.265 value. So it means that this value is less than petal length. This value is also less than petal width. The greatest value among the four is 1179. In case of ANOVA analysis, I'm talking. In case of ANOVA analysis, 1179 is the greatest value. It means that petal length is the highest responsible feature for classifying the flowers into three categories. Okay. And similarly, if you are having the results of chi-square, here also we find that the highest value is of petal length. So again, chi-square and ANOVA both says that petal length is playing very important role in case of classifying the flowers. The next feature which is playing important role is petal width. So petal length and petal width are the two important features which are playing very important role in classifying the flowers. So clear? So this is about deciding the importance of feature. Okay, now we have to just check for like if I want to plot it, I want to plot it in a scatter plot. So let's see how we can, this is the visualization, how to visualize the data. And also if you want to check the statistics, feature statistics. So there is a widget known as feature statistics. Just have a click here, feature statistics. So this is the feature statistics. So if you don't find it here, so just right click and search. Just right click and search like feature statistics. So feature statistic will be available. So if you want to see the feature statistics, so just link file to the feature statistics. So in feature statistics, you will see this thing. For the petal width, mean is 1.199. This is the mean value, median value, dispersion, minimum value, maximum value, and the missing values. Missing values, there are no missing values in this data set. That's why it is 0. Okay. So mean value for petal length is 1.199, median is 1.3, dispersion is 0.635, minimum value is 0.1, and maximum value is 2.5. So this is the statistics of the data set for all the features. Now, what does this distribution means? Actually, this distribution means how the data is distributed. Now, you can see there are 3 different colors. 3 different colors means 3 different flowers. So first flower is Iris setosa, second is Iris virginica, and green is Iris versicolor. So in the first distribution, petal width, if the petal width is highest, it is among the Iris setosa. Then few are, if it is in the middle, so it is Iris virginica. And if it is at the last, it is Iris versicolor. So this is for the features, for each feature, how the data is distributed for 3 different flowers, it is shown in the distribution. Clear? So this is about the feature statistics, where you are getting the statistics of all the features, 4 features, and also for the categorical target variable. So again, I will repeat, these 4 are the features, and this is my target variable. What target variable means? Target variable, we are predicting, it should be categorical, and we are predicting which type of flower it is based on petal width, length, sepal width, and sepal width. Clear? This is all about statistics. And the third window that I will show, okay, rank and feature statistics. This is about statistics. Now visualization. Now comes data visualization. How you will visualize the data? So just I will click scatter plot is one way of visualizing the data. So there are many ways. If you will go in the widget here in visualize, there is scatter plot, there is box plot, there is line plot, there is bar plot, violin plot. But I will show you the scatter plot, how it shows. Then we will see few other visualization techniques, how we can visualize the data. So see, once I click it here, it is showing you the graph of petal length and petal width. So on x-axis, petal length is plotted. On y-axis, petal width is plotted. Why it is showing for petal length and petal width? In the rank feature, we have seen that, just a minute. In a rank feature, we have seen that the most important feature is petal length and petal width. That's why the best formation of the grouping will be done in scatter plot using petal width and petal length. So here you can find informative projections. So this is the best one it is showing. And if you want to see the other one, I will show you how to see. But from this graph, from this scatter plot, you can easily see blue is Iris setosa, red is Iris versicolor, and green is Iris virginica. So blue, if the petal width and petal length are less than, petal length is less than 4 and petal width is less than 1.4, it belongs to Iris setosa. Okay, then if the petal length, petal width is above 1.6 and petal length is above 4, then it is Iris versicolor. And for Iris virginica, it is for upper class, where higher, more than 2.4 and more than 6. So this part belongs to Iris virginica. Okay, now you can see that some of the samples of green are here. So these samples are known as outliers. Outliers means they are not performing similar to the one which are from the same class. These 3 are actually from Iris virginica, but they are in the group of Iris versicolor. So that's why these 3 are known as outliers, because they are not following the same pattern as these data points, which are in the class of Iris virginica. Clear? Also, this point, red, this point, these 2 points are also outliers because they actually belong to Iris versicolor, but they fall in Iris virginica. Okay, now if you want to see other sepal length and sepal width, so you can click here, find informative projections. Okay, if you will say start, it will give you the best. So it will give you the 6 options. The best will be the first. First is the best option that they are showing to you. Then second, this is the other option. Like this is the petal width on x-axis and sepal width on y-axis. Then if you want to see petal length and sepal length, so this is the thing. Petal length on x-axis and sepal length on y-axis. So here you can just click and see the different projections of scatter plot. Okay, so the best one is petal length and petal width. The topmost is the best one. So here you can generate various graphs and just you can analyze your data. This is the data visualization. Next is violin plot. I will show you one violin plot as well. There are many. I will just tell you 2 or 3. So in violin plot also, just see, this is violin plot. So violin plot is like you can see here, it is the best. It is about iris. The iris is the flowers and sepal length. It is showing on x-axis it is sepal length, on y-axis it is the target variable iris, that is flower names. So you can see in violin plot what we can see. Actually, the mean value of iris setosa is this one, this value. Okay, so if you want to see the values, you can just order subset, you can drag plot, you can strip plot. So the mean value you can see it's the mean value of iris setosa is near to the 5. Okay, if sepal length is 5, it is iris setosa. But it is distributed. How it is distributed? It is distributed from 4.2 to it is distributed from sorry, let's stop that. Okay, it is distributed from 4.2 to 6. Similarly, this point is the mean value, and this black range is the IQR, interquartile range. So interquartile range, all these points are belonging to the particular flower. But these points, which are at the narrow end, these points are outliers. These points are considered as outliers. So this is also here also we can see the visualization of the sepal length of the feature along with the target variable. This is for sepal length. You can go for petal width also. You can go for petal length also. You can go for sepal width also. So this is a different way of visualizing the plots. This is another way, violin plot. Okay. Now, there are many things, but I just told you 2. Again, if I want to show you 3, the Chilote plot. Chilote plot is also very famous. So just click here. Visualize the data using Chilote plot. You can see this is iris setosa 50, iris versicolor 50 instances, and iris virginica 50 instances. And how to detect the outliers here? So if all the points, in case of Chilote plot, if all the points are above 0 or at 0, those are correct points. And which are below 0, which are having the negative score of Chilote, they are known as outliers. So you can see iris versicolor is having 2 outliers, and iris virginica is also having 2 outliers. Okay, so in this way you can detect the outliers. Outliers means they are not behaving, actually they are belonging to one class, but behaving as the data points of other class. So this is about the visualizations. So just I'm showing you this was the statistics part. This was the visualization part. So let's go back to the statistical and visualization part of this. So we have completed statistical analysis. We have completed data visualization. I've showed you how to load the data. Then just a minute. Function F5. Okay. So I've shown you how to load the data. Then statistical analysis we have seen, then ranking we have completed. So I have already explained the ANOVA analysis. And see, for each of the, if you want to read the theoretical part about them, so I've given you the reference for it of the orange tool. So just you can click on this link, you will find the references for it. And you can just read this content to get a better clarity. So here also for rank, a reference is given. You can understand the rank, how to implement it. For data visualization, I've shown you the violin plot. I've shown you the Chilote plot. The references are given below. Okay, now this was a scatter plot we have seen. Now we will move to supervised learning. Supervised learning, first to understand supervised learning, we have to understand the classification algorithms. So see here today, as the time limit is only of 1 hour, I have to complete various things into it. That's why I'm just giving you a basic theory of 3 classification algorithms. And also I will show you how to implement the 3 classification algorithms using Orange tool. Okay, so this is the neural networks. Actually, in last lecture, many questions were regarding the neural networks. That's why I've targeted this topic. So what is neural network? So talking about a neural network, do you know how the brain functions? Brain is also having the neurons. They are connected with the signals. Similarly, like a neural network, like here you can see a simple neural network, which is having an input layer, hidden layer, and output layer. Okay, so our brain is also formed in such a manner. These are known as neurons and these are signals. Okay, so similar to our brain, how our brain functions. Actually, neural network is developed on the basis of the similar functionality of the brain, human brain. So you can see a neural network. So this is, I have given you 2 diagrams here. This is the functioning of single neuron. This diagram is giving you the functioning of single neuron, this one. And while this is the complete architecture of a neural network. So from the first figure, it's how a single neural network functions, how the single neuron functions. And this is about how a complete neural network works. Single neuron means this is a single neuron. This is a single neuron. This is a single neuron. So in this neural network, in the input layer, there are two neurons. In the hidden layer, there are 4. And in the output layer, there is 1. Okay, in this example. Okay, so how to decide how many neurons should be in input layer, how many neurons should be in output layer, and how many neurons should be in the hidden layer, that I will tell you later. But right now, let's see how a single neuron functions. Okay, so like actually what happens in our brain? If suppose I'm seeing this first word, classification, that comes to my eyes, CLASSIFICATION. So I know this is classification. So how this I know? I was trained at some moment that if this spelling you see, then call it as classification. Whenever you see this spelling, you call it as a classification. I was trained in my schools. Okay, so today I am calling it as classification, not as neural network. Okay, so we are trained. How our brain works? Our brain stores the information, processes it, and then predicts it. Similar way, the neural network works or any other machine learning algorithm works. Okay, now see. Similar way, there are neurons, there are signals which are connected, connecting each neurons to every neuron. Now let's focus on how the processing, what is the mathematical processing behind this one neuron. So how it processes. So behind this first neuron, this is my neuron, suppose. This is my first neuron, input neurons. So how it is functioning. So for every input, see, the first layer is the input layer. So whatever inputs you have, that much neurons will be there. Like for our example, for our data set, there are 4 features. Sorry, there are 5 features. 4 are features and 1 is a target variable. So there are 5. So we will have 5 input neurons in the input layer. So depending upon the number of features and a target variable you have in the data set, that much neurons will be there in the input layer. Okay, so that is for our example. Our example are having 4 features and 1 target variable. That's why we will have 5 neurons in the input layer. So okay, so this is the value x1, x2, x3, xn. These are the inputs. Okay, it is having some value like 1, 2, 3, 4. Okay, and then each signal is having a weight W1, W2, W3, and Wn. Okay, so what happens? This is W1, W2, W3, and Wn. These are the hyperparameters. Hyperparameter means they will modify continuously when the neural network will train. They are modified by using a theorem backpropagation continuously when the neural network is trained. So initially they are randomly selected. Initially they are randomly assigned to 1, -1, -2, anything, any random number. But when the neural network is completely trained, these values are known as hyperparameters. Okay, and there is a bias. Generally, the bias is 1. We generally keep the bias as 1B. Okay, so what happens? How the calculation of this neural network happens? So if you want to have there is an activation function. There are different types of activation functions like 10H, ReLU. The complete description about the activation function and the neural network you can find in the below link. And also I have shared one PDF of the book with Carla. So might be she will share with you the PDF of that book. So the complete introduction about the activation functions, neural network is given in it. But I'm just here giving you a brief introduction about it. So activation, what is the role of activation function? There are different types of activation function, and each activation function have a specific role. Like we have ReLU, rectified linear unit. We have 10H, hyperbolic tangent. We have sigmoid. So there are different activation functions that we are using that help us to give a predicted output. Okay, so how this predicted output is calculated? It is calculated as y predict is equals to summation of I equals to n. N means number of inputs, number of neurons in the input layer. And then xi into wi plus b. Xi is the input into wi weight plus b. So this is the formula for calculating the value for the next neuron, which will be passed to the next neuron. Okay, but these weights, each and every signal will have the weights, and these weights will get updated at every training of the neural network. And once they get perfect weight, then we can say that our neural network is trained. So this is a simple neural network architecture. Okay, now I will just tell you, like for our data set, input neurons will be 5 because we have 5 features. In hidden layer, it depends upon you. It is again a hyperparameter. Hyperparameter means it depends upon the programmer how many neurons they want to keep in the hidden layer. They can keep 1, they can keep 3, they can keep 4, they can keep 5. And even number of the hidden layers also depend upon the neuron. There is here in this diagram, there is one hidden layer. You can keep 3, you can keep 4, you can keep 5. It depends upon a programmer. Okay, so actually what we are doing, we are experimenting. For one hidden layer, for one neuron, what is the output? For one hidden layer, for two neuron, what is the output? For one hidden layer, for 3 neuron, what is the output? We are checking it like this, and whichever neural network give us best performance, we select that. Okay, so the number of neurons is the hidden layer, and number of hidden layers is the hyperparameter. And last is the output layer. In the output layer, the number of neurons will be based upon the classes in the target variable. So we were having 3 classes in the target variable: iris setosa, iris versicolor, and iris virginica. So there will be 3 neurons in the output layer. Okay, so the number of neurons in the output layer will be equals to number of categories in the target variable, and number of input neurons in the input layer equals to the number of features in the data set. So this is about the neural network. Next, we are moving to a decision tree. Now, decision tree is a machine learning algorithm which develops a tree like this. This is a tree. See, this diagram I will show you how to generate this diagram in orange, but I will explain you how this diagram works, how this diagram is developed by the machine learning algorithm, decision tree. So decision tree works by, it will create a tree. There will be a root node. This is known as a root node. There will be the child. These 2 are the children of the root node. Then this is again a parent. There are the child. Then there are the child, and this process will continue until you will classify all the 150 instances. Okay. So how they classify? First, it will select any random root node. Okay, it will select any random root node. Then, by using the information gain, it will calculate the information gain of each feature at each level, and it will then classify each feature, and depending upon the information gain, the one who is having the highest information gain, that will be the root node. Okay, so I'm not explaining you the exact mathematics of decision tree. You can get the exact mathematics of the decision tree on this link, also in the book. But just I'm giving you the brief introduction how decision tree is developed. So you can see a figure Decision tree is developed in this manner. Okay. Now, iris was like we can see from this diagram, if iris versicolor, in case of iris versicolor, the petal length, if the petal length is less than or equal to 1.9, okay, then it will be iris setosa. And if it is greater than 1.9, then it will be iris versicolor. Okay. So if you are saying the petal length is less than 1.9, then it will be 100% iris setosa. And if it is less than, if it is less than equal to 1.9, it will be iris setosa. If it is greater than 1.9, it will be iris versicolor. Okay. Now again, at this point, there is a petal width. So if the petal length is greater than 1.9 and petal width is less than equal to 1.6, then it will be iris versicolor. Again, there will be a condition. If the petal length is less than equal to 4.9, then it will be 100% iris versicolor. And if it is greater than 4.9, then it will be iris burgeoning, and it will be 75%. 75% probability of having iris burgeoning. Okay. Now, if the petal length is greater than 1.6, so it is iris burgeonica, then it will check what is the percentage of iris burgeonica. 94.7%, it is iris burgeonica. Then it will check petal width. If petal width is less than equal to 1.8, then it will be iris virginica, 81.8%. Again, it will check the sepal width and it will go on. Okay, so this is depending upon the values. It is it is making a tree form, and it is classifying the samples into the 3 classes. The detailed of information gain and theory, you can find it on this link. Next is KNN. KNN is K nearest neighbor. Okay, so what is K nearest neighbor? So these are the steps for this algorithm, and actually it is very simple algorithm. What they do, suppose there are 2 categories, category A and category B, and there is a new point, blue color new point, and we want to decide that this new point belongs to which category, whether it belongs to A or B. Okay, so this new point, to check this whether it belongs to A or B, you have to calculate the distance. How you will calculate the distance? You will calculate the distance of this point to nearer point of this category A. What is the distance between 2 of these points? What is the distance between 2 of these points? What is the distance between this blue and orange, this blue and orange? And to calculate the distance, here is a formula for the Euclidean distance. So what is Euclidean? There are many distance formulas, Mahant and Mahanobolis, but mostly Euclidean distance is very famous. So I'm explaining you about this because as the time, we don't have so much time. I have to cover everything in a single 1 hour. So just I'm explaining you Euclidean distance. Other you can go through other the links or in the book which is available. So you can find out the various distance formulas as well. Okay, so to calculate the distance, this is the distance. Okay, so to calculate the distance, we are using the Pythagoras theorem. You might be knowing about the Pythagoras theorem. So we have the x1 point, which is having the coordinate x1, y1. We are having x2 point, having the coordinate x2, y2. So the distance d is equals to under root of x square minus x1 whole square plus y2 minus y1 whole square. Okay, so by this formula, the distance is calculated. And whichever the distance is smaller, in that group, this point belongs. Like this distance from this point is smaller than from these 2 points. That's why blue point will belong to category A. Okay, so this is way the KNN performs. Now next is, I have told you about 3 classification algorithms. Now how to evaluate those classification algorithms? So the best way of evaluating the classification algorithms is the first matrix is confusion matrix. Okay, so the confusion matrix, what confusion matrix tells you? If say what is the actual value of the sample? Actual value suppose is yes, no. If we have 2 values, actual value is yes, actual value is no. But the predicted value is yes and predicted value is no. Suppose if actual value is yes and predicted value is yes, then it is true positive. True positive means actually the value of the sample is yes, and also it is correctly predicted That's why it is true positive. Okay. So true positive is a correct, true positive is the correct one. If actual value is no and predicted is also no, then it is true negative. So actually true positive TP and true negative TN are the correctly classified samples. So true positive and true negative are the correctly classified samples. This is for two class problem. Our data set is having three classes: iris versicolor, iris virginica, and iris sedosa. Okay, so this confusion matrix is only for two classes. Okay, it is very easy to explain. That's why I've taken the example of two classes. So the correctly classified are true positive and true negative. Now suppose if the actual is no, but it is predicted as yes, so it is wrongly predicted. That's why we say it as false negative. They are false negative. Actually they are yes, but they are predicted as, actual they are no, but they are predicted as yes. That's why they are known as false negative. And similarly is for, if actual is yes, but predicted as no, they are false positive. Okay, so this is a simple confusion matrix for understanding the how we are evaluating the classification algorithms. Next is classification accuracy. So depending upon these four values, the classification accuracy is calculated. So the classification accuracy is equals to TP plus TN, true positive plus true negative, which means correctly classified samples, total number of correctly classified samples. These true positive and true negative give us correctly classified samples, while false positive and false negative give us wrongly classified samples. Excuse me. Okay. So classification accuracy is totally correctly classified samples divided by total number of samples. Total number of samples means true positive, true negative, false positive, and false negative. So if you are combining all these four classes, it will be total number of samples. So total number of samples in our class was 150. So it will be 150 here. Okay. Then there is recall or true positive rate. Recall means we are interested in true positives. True positive divided by true positive plus false negative. Okay. Precision means true positive divided by true positive plus false positive. So these are different formulas for different like evaluation matrix. Then there is an F1 score. F1 score is the combination of precision and recall. So it is 2 into precision into recall divided by precision plus recall. So recall formula is given, precision formula is given. And then there is false positive rate, FP divided by TN plus FP. So everything depends upon this confusion matrix. I hope this you have understood. Even if you have doubts, we will clear your doubts in the question answering session. So this is the ROC curve. ROC curve is a plot between FPR, false positive rate, and true positive rate. True positive rate is also known as recall. How it is calculated? True positive rate is equals to TP upon TP plus FN, and false positive rate equals to FP upon TN plus FP. So it is, and we get this curve. In this curve, we will have, it's a probability graph, and we will have the AUC, area under curve. So this value we will calculate, and this value is very important for us to understand how our algorithms are performing. So if the value is 1, so it means that our algorithm is performing 100% good. If the value is less than 1, then it means that it is performing less. So the excellent algorithm will have a graph here, 0 to 1. So if this point is nearer to this point of TPR1, then it is very good graph. It is very good. Someone has raised hand. Yeah, just a minute. Actually, we should do the question answering session at the end, I think. Carla, someone is raising the hand. So should we continue with question answer session?
If you want to do now or at the end of the session.
Yeah, we can do it at the end of the session. Yes, Jen. Okay. Jen, we can do it at the end of the session because like we have to complete the session first, slides. Then whatever question you have, we will do it at the end. Okay. Okay. So this ROC curve is a false positive the plot between FPR and TPR. Okay. So this was about the like classification algorithms and ROC, and this is the reference given. Like I have given one book of Amit Kumar Das. So you can, I have shared the PDF with the Carla, so she will share with you. Also, there is one book for pattern recognition and machine learning of Christopher Bishop. This is also very good, but it is a bit tough to understand. The language is a bit tough. Here, the language is easy. So you can prefer any of the book for further understanding. Now let's move to the orange tool and see how classification algorithms can be implemented. Now, here in the model, you have various classification algorithms. Like we have studied 3: neural network. So one is the neural network. It's hanging. Just a minute. It's just about like, it takes a lot of memory, so it's not responding. Yeah, so this is our neural network. Other algorithm we have seen KNN, and the third algorithm we have seen decision tree. Okay, so what we will do actually, see, in machine learning algorithm, we divide the data into 2 parts. To divide the data into 2 parts, why we divide the data into 2 parts? We keep 80% of data for training and 20% for testing. What happens in the training data? In the training data, what I am doing, I will give you the features as well as target variable. So in the training data, we are giving features with the target variable, while in the test data, we are only giving the features and we are predicting the target variable to check the algorithm. Like what happens in the examination. Today, I'm teaching you. So it is, I'm giving you the questions also, I'm giving you the answers also. So same happens with the training. While in the test, in the exam, what happens? We will only give you questions, no answers, and we will check your performance. The same we are doing with the machine learning algorithms. So we will divide the data into 2 parts. To divide the data into the 2 parts, there is a widget known as data sampler. Okay, so I will give this complete data to the data sampler, and we are dividing it into 2 parts. 80% we will give it to the training, and 20% remaining we will give it to the, so already it is at the 80%, so I will not do anything. But if you want to make it 70%, 69%, so you can move this. So I'm saying 80% to the training. So I will give this 80% of data to the 3 neural networks. Neural network. So data sample means 80% of data will be given to that. Data sample. Okay. So all 3 are being trained. Now there are some hyperparameters, as I told you. If you will click here, you will find neurons in hidden layer. Now you have to decide that. I've told you, you have to decide how many neurons you want, how many hidden layers you want. But here I am taking only 1 hidden layer, and in 1 hidden layer, I'm keeping 25 neurons. If you want to keep 2 neurons, you can keep 2, you can keep 1, and you can experiment and find the best number of neurons. Okay, so you have to manually do that. So how many neurons you want? Like suppose if you want multiple layers, so you can see I want 2 neurons in first layer, then I want in second layer, I won't have 2 hidden layers. In second layer, I want 2 neurons in the first layer, and in second layer, I want 3 neurons. Okay, so in this manner, so you have to go like how many neurons you want. But right now, I'm keeping only 1 hidden layer, and it is 2. Suppose 2 neurons are there. Okay, so it will train for the 2 neurons, 1 hidden layer with 2 neurons. There is an activation function. You can select the activation function. I'm suppose selecting 10H, or you can select ReLU, or you can select identity. By selecting different activation function, you will get different results. There is an optimizer. Optimizer, generally Adam we are selecting. Adaptive, like it's very famous for the neural networks, Adam. So Adam optimizer generally gives a very good. So these are known as hyperparameters. These hyperparameters you have to change, and you have to check for the results. Okay. So maximum number of iterations is 50. That is about the epochs. Generally, you have heard in neural networks, how many number of training, you have to give the number of training. So the maximum number of training will be 50. That you can keep 10, 20, whatever you want. Okay. So these are known as hyperparameters. By changing this, your result will also get changed. Fine. Next is KNN. In KNN, just you have to select the distance matrix. We have seen Euclidean distance. Okay. And number of neighbors also you have to decide. Like KNN means K nearest neighbor. So we have to give the value of K. So K value will be for how many neighbors you want to check the distance. I'm saying I want to check for 5 neighbors. Okay, you can check for 2, you can check for 3, you can check for 4, like depends. You can check the you can keep any key. Next is tree. Okay, in tree also you can have different, there are different hyperparameters, like minimum number of instances in leaves. I'm saying that minimum number of children should be 2. Then do not split subsets smaller than 5. So these are the values that are actually by default here. I'm keeping the by default values. You can change it. And also, what should be the depth of the tree? Like in this case, the depth of the tree is, what is the depth? So 1, 2, 3, 4, 5, and 6. The depth of the tree is 6. Okay. While here, you can keep the depth of the tree depending upon that I'm keeping 100. That is like we will not have 100 because our data set is, we are having only 5 features. But if there are 20 features, then might be the depth can be 100 as well. So right now I will keep 6. Okay, or I will keep 10, better way, 10. Okay, fine. So this is the parameter tuning. Now to check the performance, of these algorithms, there is a widget known as test and scoop and confusion matrix. So this is the confusion matrix. This is test and scope. So test and you have to connect all this to the test and scope. Okay. So this is like test and scope. So you can have, okay, there is no, so because I have to connect the data as well with this test and scope. So once connecting the data, so this is the result. So you can see this is the accuracy you obtained. So the accuracy, CA is the classification accuracy, F1 score, precision, recall, and AUC. This is test time and train time. How much time is required for testing? How much time is required for training? So you can see our neural network is performing very bad as compared to KNN and tree. KNN and tree are having 99.9% accuracy. KNN is having 99.8% accuracy, while neural network is having 80.6. So if you want to increase the accuracy, just change the number of neurons here, do some fiddling, like I'm keeping number of neurons in the hidden layer as 25. Okay, I'm changing the activation function also to 10H. Let's see what is the result now. It is still 84. It has not been increased much. It was 80 earlier. Now it is 84. It is increased by 4. So just doing some tweaking the code and checking out, you will get the result. This is the training result. Okay, we are providing the training result. Now, if you want to check for the test result, so you have to provide this here and you have to change it as, sorry, now this is data sample. Okay, I will take the another test and score. Another test and score. Here I will give the remaining 20% of the data. So this is here. I will just click here and I will say remaining data as test data. What this means? Remaining data as test data means 20% of the data will be my test data. So if it is a test data, it means that you are not providing the labels. Okay. So now you have to connect this test and score with these neural network training as well. So this is your testing result. This is your testing result. Test is what happened. Yeah, you have to give this data as well. Sample data. Yeah. So this is your testing result. So your testing result for, testing result for KNN tree and neural network is 97.9, 97. This is AUC. Classification accuracy is 96.7, 96.7, 93.3. So neural network is performing least, but in case of training, it was giving only 84% accuracy, while here it is giving 96.7 and 93.3. So these are the values. This is classification accuracy, this is F1 score, this is precision, this is recall, and this is AUC. Okay, so here in the testing results, KNN and tree are performing to say similarly, and neural network is performing a bit less, but as compared to training, it is good. So we are comparing the results here. Okay, now if you want to see the confusion matrix of all three, so like I'm giving you the confusion matrix of the data. Now see, we were having 150 instances, right? But here we are having only 120. Why? Because This is 80% of the data. We have given 80% of the data to the training. So that's why there are 120 instances. So this is the real classification. 35 instances are for iris setosa. So it is correctly classified. Only one instance is wrongly classified. Actual it is iris versicolor, but it is classified as iris setosa. It is predicted. Okay. Now, correct samples of iris versicolor are 25. It is correctly classified. For iris virginica, 26 are correctly classified. This 20 are wrongly classified. Actually, they are virginica, but classified as versicolor. And this 13, actually, they are versicolor, but they're classified as virginica. Okay. So these are wrongly classified samples. And these 3 diagonals are the correctly classified samples. This is for neural network. This is for KNN. This is for tree. There is a different confusion matrix for all. So you can see in tree, only 2 samples are wrongly classified. They are actually versicolor, but they are classified as virginica. So this was about the confusion matrix. Now ROC curve. So I explained to you. Let's see the ROC curve working. I'm giving you this for the training results. You can also generate it for testing one. Now see, this is for the all three. All 3 are performing well generally. So there are all 3 are performing having 1. Only neural network is having 0 point less accuracy. So the performance in the AUC is same for all the 3. That's why you can just cannot see all the 3 graphs together, because the performance is all here. All 3 are pointing to this point. So this is the ROC curve for the 3 algorithms. So this was all about the today's session.